Okay, we will be going through the quicksort in place algorithm. Now, in order to do so, we will be going through three core skills and then walk through the step 1, 2, and 3 for the whole algorithm. Now, just a recap, a quicksort, we will use the last element as our pivot so that we can partition the array into two halves, the left and the right. Now the left half will contain all the elements with value lesser than the pivot, and the right half will contain all the elements with values greater or equal to the pivot. Then we will repeatedly call the partition. Partition is a function. Repeatedly call this partition recursively until it contains only one or no elements. Then the result will be a sorted array. Let's go through our core skill number 1. That is swapping two elements in a list. Now, traditionally, in other programming language, we will have to make use of a temporary variable to store the value of one of the uh, element in the array, and then assign the index 3 element to index 1, and then assign back the temporary variable to the index 3. But in Python, we can actually do the direct assignment by exchanging the value of this element in index 1 and index 3. Okay, and this will do the job. So you can see that the index 1, which is a 3, and index 3 is a 2. 3 and 2 will swap its position. The 3 and the 2 has indeed swapped its position. So that is our core skill 0. To execute quicksort sorting algorithm, we need to define some variables. The sequence, of course, the array itself, and then the start. The start will always from the 0 index, and the end, that will be the last element. Okay, so that will be the length of the sequence minus 1. We will be using the last element as our pivot. So hence the value of the pivot will be the sequence at this end. Okay, the low index we will start from the start, and then the high index we will start from the right hand side, excluding the pivot itself. So that will be the n minus 1. Okay, we have defined the variables. The first important core skill is to be able to move the low index starting from the 0 towards the right. That means that we want to have the low equal to low plus 1, and that will move it towards the right. And when do we execute that? We will continue to do so when the value at all these indices are actually smaller than pivot. So the moment it come across something that is bigger or equal than the pivot, it will stop. Okay, so take a look starting from the left. We have the sequence 137289065. Starting from the left, which is a 0, the pivot is 5, so the next will be a 3 and 7. 7 is bigger than the pivot, so that's where it stops. So the low index will be 2. Similarly, we also want to move the high index from the right hand side towards the left. Okay, and in order to move the high index towards the left, high will have to high minus 1. Okay, and when do we stop? We stop until when we see a value at the high index to be bigger or equal to the pivot. Let's run. Okay, starting from the right, now excluding the pivot, we'll start from the value 4, and 4 is indeed smaller than pivot value. So the high value will be at the index position 8. Now, once we have done that, we want to be able to swap the two elements, the low and the high element. And then how do we do that? Sequence the low, sequence the high, and we do that by direct assignment. So the low will now become the high, and the high will become the low. Okay, I'm going to run the code. So before swapping, What we have is the low index. Low index is a value 7, and then the high index is value 4. And after swapping, the value 7 and the value 4 exchange position. So for call skill number 1, we define all the variables, and then we move the low index starting from 0 towards the right, and we move the high index starting from the right hand side towards the left, and then we swap the two elements of low and high. And then after the swapping, let's take a look. Okay, so before swapping, we have the 7 and the 4, and after swapping, the 7 and the 4 exchange place. Okay, let's copy our code from the core skill number 1 and paste it over here. Now, what we want to do now is to repeatedly move the low and the high index for the condition where low is lesser or equal to high. We will put a while loop here after defining the variables. While low is less than or equal to high, and we want to repeat the following code for the condition where low is less than or equal to high. Now, in order to shift, we also need to check for the condition that low remains smaller or equal to high. And now you must remember to include this condition before checking the value, whether is it smaller than the pivot or not. Likewise, check for this condition before you check for the value of the high index element with the pivot. Before you do the swap, we will also need to check that if low is less than or equal to the high index, okay, and then we do the swap. Let's run the code. The low index is at 5, 0, 1, 2, 3, 4, 5, and that's the value 9. Now, bear in mind is that our pivot is actually 5 at the end, the last element. So you take a look at from the left. The left from 0 index to 4, these are all the value that's smaller than the pivot. And the remaining values, they are actually larger than the pivot. So by right, the pivot should stand in between the 0 and the 9. Okay, so now we'll move on to swap the position of the pivot and the low index. Okay, let's copy the code. Paste it over here for our core skill 3. Now, after iterating through, now we are going to swap the low and the pivot, okay? The value, the element at the low and the pivot. The low and the pivot is at the end, and then now the low will become the end, and the end will become the low. Let's run our code. Okay, you can see that now the index is at, the pivot is actually at index 5. So this is the element. And everything that is from the left, these are all smaller than the pivot. Everything that's on the right, these are larger than the pivot. So there you go. We have completed all the 3 core skills. Okay, we are now into step number 1 to write the function partition. Okay, let's define our pivot. Our pivot will be the last value, last element, so that is the sequence at the end. And then our low index, that will be from the start. And our high index, that will be one element away from the end, which is away from the pivot, so that will be n minus 1. Let's copy from our core skill 3 the algorithm that we have developed so far. The while loop. Okay, so let's watch out the indentation to cast it inside a function. So while low is less than or equal to high, okay, we repeatedly shift the low to the right, we shift the high towards the left, and if low is smaller than high, we swap the low and the high value, and then eventually after one round of checking through all the elements, we swap the low and the pivot value. and then the partition function will return the low as the pivot index. So return low. So let's test our code with this following sequence, and then it will show us what happened after one pass of the partition. Okay, after one partition, our pivot is at 5, index 5, or on the left, they are all smaller than the pivot, and everything that's on the right is larger than the pivot. Okay, so with this in mind, if you take a look at the right partition, namely the 6, 7, 8, 6, 7, 9, and then these are from index 6 to 9. If we try to partition the right side again, okay, namely we try to partition from starting from 6 to 9, let's see what happened. When we try to partition from 6 to 9, 9 will be taken as the pivot. And now the new, since 9 is the largest number, it remains as a pivot, and everything that's on the left side is still smaller than the pivot. Okay, so now we focus on these three values, 8, 6, and 7. So namely that will be the index 6 to 8. So we try to partition this portion, the left of the pivot 9. Okay, we try to partition this from index 6 to 8. And now the index position is 7, which is this element. And you realize that the left and the right, these are smaller and larger than the pivot itself. Now you realize that the right partition is already fully sorted. Okay, now let's take a look at the left partition. Okay, the left partition 1, 3, 4, 2, 0. These are from index 0 to 4. And let's try to partition this again from 0, starting index and the end index 0 to 4. And after the swap, okay, 0 is still the index, the pivot. And everything that's on the right of it, they are all larger than the pivot. Okay, so we concentrate on this 4 value, 3, 4, 2, 1, and these are the index 1 to 4. And let's partition this further from index 1 to 4. And after the swap, the index position now is at 1, and everything that's on the right hand side is actually bigger than 1. So next we concentrate on these three value 4, 2, 3. 3 will be taken as the pivot. Okay, so we will partition uh, from index 2 to index 4. And then let's run. Our pivot now resides at index position 3, and on the left hand side it is smaller than the pivot, on the right hand side is bigger than the pivot. So all in all, after a few rounds of partitioning, we actually get a sorted array. So for step number 2, we want to be able to partition the sequence recursively. Okay, now what we're going to do is that we're going to define mid. Mid is actually the pivot index, and then we have the left segment starting from the start to the mid minus 1, and then the right segment from mid plus 1 all the way to the end. Okay, so we will call this function qsort. So if we are doing a start lesser than n, which rightfully be the case, define our mid to be the pivot index. And how do we get the pivot index? We can get it from the partition function. Calling the partition function on the sequence with the start value and the end value. Okay, so now we have the mid, which is the pivot. We will have a left segment and a right segment. The left segment will be the sequence starting from the start all the way to the mid minus 1. So that this is the left segment. And then the right segment will start from the mid plus 1 all the way to the end. So we have the left and the right. And what we're going to do about it, we want to call on this quicksort. That means quicksort is actually our partition now. We want to recursively call it, okay, quicksort. And after repeatedly doing the partitioning, eventually we will obtain a sorted algorithm. Let's return the sequence. Okay, we're going to try with this sequence, and then we're going to start from 0 all the way to the last element. There it goes. By recursively calling on the partition, now we actually have a sorted array. Okay, now whenever we try to sort a sequence, we would just call quicksort on the sequence. We do not want to specify the starting index and the ending index. So hence, we are going to write a wrapper function to help us call the qsort. So when we do a quicksort, we will define the start variable to be 0, and then the end variable to be the length of the sequence minus 1, and then we call the qsort for the sequence with using the start and the end. After which we will return the sequence. Okay, so we are just going to call the quicksort on the sequence, and straight away we will get a sorted array. You may now want to put the three functions together: the partition, the qsort, and the quicksort. There it goes. You have the quicksort algorithm. Now we're going to generate n random number, unique n random number, and let's check after executing the quicksort. It is sorted in a ascending order. So far we have been using the last element as our pivot. Okay, we were going to try to modify our existing partition functions and see whether we can use the first element as the pivot. So this is the partition that we have written in our previous task. The pivot is defined as the last element. Let's change this to the start. So that would be the first element. And then since we use the first element as our pivot, our low will have to start one index after that, so that we have the plus 1. And for our high index, we will start from right from the end. The condition to continue with the loop, low less than or equal to high, remains the same. Shifting of the low index, shifting of the high index towards the left remains the same. Swapping of the low and the high index value elements remains the same. Lastly, when we want to swap the pivot, which is our start, and instead of swapping with the low index element, we are actually swapping with the high index element. So the pivot will now be the high, and then the high index element will now be the pivot, which is at the start. Previously, the low is index is actually the pivot position, but now the high is actually the pivot index position. Okay, now let's take a look. Let's run our code. So when we have a sequence 1 and we are using the first index as the pivot, so 6 will be our pivot. Okay, and after calling the partition once, our pivot is now at 6, index 6, 0, 1, 2, 3, 4, 5, 6. So this is the pivot. Everything that's on the left is smaller than the pivot. Everything that's on the right is bigger than the pivot. So we have successfully modified our partition function to use the first element as the pivot. Okay, you may want to test this code with your quicksort and the qsort and see whether it will sort the random sequence. Okay, There you go.